It's another first timer. It's Cat Green. Woo!
So my presentation is on mathematical aesthetics, which is basically using maths to find a fundamental idea of beauty, if it's possible. So we're going to have a look at a couple of attempts of it. I'll start with a couple of basic ideas of what beauty means. So for Kant, you can't find a fundamental idea because beauty is completely subjective. But Pythagoras on this side, much more my kind of guy, is implying that maths and art are intrinsically linked. So the first theory we're going to start with Berkhoff, and he believes that all forms of aesthetic experience are described mathematically. And he was a very prominent, well-thought-of mathematician before he wrote this book, where he argued that aesthetic measure of an art form is equal to its order divided by its complexity. And it works quite well here when you look at shapes, when the order is the number of the lines of symmetry and the complexity is the number of sides. But it doesn't work quite so well when he tries to apply it to poetry here, because there's about 30 pages on how to calculate the order and complexity in terms of rhythm, sounds, rhyming, and it doesn't really give the nice, simple answer that I would like to find. So another way people have tried to attempt to find beauty using mathematics is with triangles. So this is Plato and his favourite triangle, which is half of an equilateral triangle. And he liked it so much because you could make loads of different shapes using the triangle. I'm sure you've all heard of the claims like that triangular composition is used so much in art, especially in Christian art, because Holy Trinity and the symbols for man and woman. So next we're going to look at Phidias, who was a sculptor in ancient Greece. And he was said to have used this ratio phi, hence the name. And Wikipedia did not explain how he found it, but I reckon it was something like this. It was the first known written definition of phi was by Euclid, who found it this way, when he noticed the ratio between the smaller part is in the same proportion to the bigger part as the bigger part is to the whole. So he solved that to try and find what the number is, and it's phi. So the ratio is found a lot in pentagons, you can see here. It's all over the place. There's also a lot of cool mathematical properties of the number. So 1 over phi is phi minus 1. And it's also the ratio in reverse if you wanted to go from the big part to the small part. Also, the formula in the top left can be expanded recursively to get a continued fraction, which turns out to be 1, 1, 1, 1, 1, 1, which is cool, I promise. It's really cool. So you probably recognise this spiral as a Fibonacci spiral, but that's not Fibonacci. That is Pingala, who is an ancient Indian mathematician who wrote about the sequence way before Fibonacci. And he found it whilst studying all possible permutations of Sanskrit poetry, which is much cooler than the way Fibonacci found it when he was thinking about how rabbits multiply over time. But the really cool thing about the Fibonacci sequence is that if you take the nth term and divide it by the n-1th term, you get a convergence to the golden ratio as n goes to infinity. So an infinitely big number in the Fibonacci sequence divided by its predecessor is phi. That's the maths over. So we're going to bring it back to art. So here's the Parthenon, where Phidias had a bit of a role to play, and you can see all the ratios, a little bit tenuous, but they're there, whether it was by design or they just thought they looked nice and it happened to be there. Either way. Of course, Leonardo da Vinci, if anyone saw this CBBC series, it's very good. And his Vitruvian Man, which is the perfectly proportioned human being. And you can do these measurements at home as well. That was my childhood with a tape measure. Also in music, you can find it. This is Debussy, and this is a piece of his, the Dialogue du Vent et de la Mer. And it's set up in terms of bar lines and recurring motifs, and it sort of creates a wave effect that you can hear in the music. So it's also found in nature a lot, and so are we seeing the beauty in nature because the ratio's there, and it makes sense because it's sort of showing this exponential growth as well as like balance when you can find it in trees and the numbers are all golden ratio numbers. So can we use it to judge beauty in people? So here's me and Jennifer Lawrence, and as you can see, my number's slightly closer to the golden ratio, so I am mathematically prettier than Jennifer Lawrence. So finally, I think I've shown you I've tried to show you that there's beauty in phi for its own sake. So I know which way I'm swiping.
Thanks for watching. If you enjoyed this video, you can see others on the Bettakultcha YouTube channel. Subscribe now and you'll be notified when new ones are uploaded.